Welcome to CCNA Routing and Switching Connecting Networks Chapter 2 lecture. In this chapter, we're going to describe the purpose of LANs, look at their operation and services that are available through LANs, then discuss various private and public WAN technologies and how they relate to building a network, and then also talk about appropriate WAN protocols for specific requirements. Why a LAN? Well, first off, what is a WAN or a wide area network? It is a collection of LANs that are connected together over a wide geographical area. Now, this could be in many ways. It could just be multiple buildings in different parts of a city. It could be multiple networks across the world. WANs really have a fairly large definition, but anytime you're connecting two remote sites over a long distance, then typically we consider that to be a WAN. It even includes items like telecommuters or remote users who are possibly traveling for a corporation and then connecting via either dial-up or, more than likely this day and age, through VPN. So why are they necessary? Well, it's to connect across vast distances. Most companies cannot afford to lay their own cables across the Atlantic or Pacific. For this reason, they're going to have to piggyback their traffic on larger ISPs and regional ISPs in order to get their traffic from one area to another. Now, we also need WANs because in this day and age, we receive services from so many different places. We connect to data centers in North America, South America, Europe, and it's really, without WANs, we wouldn't have the internet we have today. In fact, you could say that the internet is the largest WAN in existence. Now, what we're going to do is we're going to start out with a small company called Span Engineering. They're a small company that started out with just a small office. They have basically 15 employees or so, some engineers, and in the beginning it was perfectly fine to have just broadband access to the internet. Now, one of the things I always get kind of tickled about is the idea of high-speed internet in the home. We talk about high-speed internet, and if you've got 15 megabits per second in the United States, then you've got a pretty quick internet connection in the US. If you've got a simple LAN connection, though, your typical connection is a gigabit, easily a gigabit. So when we talk about high-speed internet and we talk about it in terms of WAN connectivity, it's really not as fast as our LAN speeds. However, having said that, it's much faster than it used to be when we used dial-up modems at 2400, 9600, and then 14.4 and so on and so forth. This company, Span, started out with a very small network. It started out with a broadband internet access, and everything was fine until they needed to expand. Once they expanded to several hundred employees, had to get a bigger building. They implemented a concept we've already seen before, which are VLANs, inter-VLAN routing. They implemented access points to do wireless connectivity, and they also had to bump up their internet speed so they're able to have a faster pipe to the internet. They also put in a firewall, a dedicated firewall, instead of just a DSL or cable modem that had a router connected to it with firewall feature set and routing built in. From there, they built out, now they have branch networks. So now we suddenly have multiple sites in different areas, possibly of different areas of a city, single city, or possibly even different areas across a country. Now, once they do this, there's a couple ways that Span could create their network. One would be to use a private cloud, and that would be a cloud that they build out and that they control the devices in that cloud. Doing that is very expensive, so those are what we will call in the future chapters or future sections of this particular chapter leased lines. Well, to own your own leased lines between your central offices and regional offices is very expensive. More than likely what they're doing is they have internet connectivity to an ISP or multiple ISPs in different areas, and then those ISPs provide the services to move their traffic between their central office and the remote offices, regional offices, and those types of things. We'll talk about some of those technologies, but it could be frame relay, it could be ATM, not very likely this day and age, it could be Metro Ethernet, very, very common now, to where you actually just lease fiber connections from your central office to, say, a remote branch office in the same city. Or it could be something like MPLS cloud that you connect to, and it will move the traffic across it and have it delivered to the correct remote office. Here we see span has now gone international. So we've got people across the world. We've got a telecommuter in England. We've got a regional office in the center of Africa, a regional office in Brazil. You've got central offices and branch offices all over the U.S. And suddenly now you've got a global enterprise network. So in other words, you've got a WAN at each one of these sites, a LAN at each one of these sites, connected together to form a large WAN for this global company span now. So when we talk about wide area networks, we're really talking about layers 1 and 2 of the OSI model. In other words, we're talking about our physical characteristics or physical standards that we're going to implement. So is it, a wireless radio frequency standard? Is it a standard using fiber optic cable? Is it a electrical standard at the physical layer? Then at the data link layer, we're going to usually run either HDLC, which is high level data link control, which is the default encapsulation on all Cisco interfaces, Cisco serial interfaces. PPP, point-to-point protocol. We'll talk more about that in later chapters. Frame relay, we'll also talk more about. Ethernet WANs, MPLS, multi-protocol label switching, and then VSAT and broadband, all of which are discussed in this chapter. But all of those technologies right here, HDLC, PPP, frame relay, Ethernet WANs, MPLS, VSAT, and broadband, those are just layer 2 framing technologies. Those are layer 2 technologies as defined by our standards organizations such as EIA, TIA, ISO, and IEEE. When we discuss WANs, it's important that we understand some terminology. Now, first is customer premise equipment, or CPE. That is the equipment owned typically by the customer that is on the customer side of the connection. Sometimes it is a device that you actually lease from the WAN provider, but most of the time it's a piece of equipment that you own. You also have what are called DCEs, data circuit terminating equipment. Now, DCEs, such as the one shown here in the picture, are typically CSU, DSUs, channel service unit, data service units, or TSUs, terminal service units that are WICs that can go into a Cisco router or Cisco device. The important thing to remember about DCE devices is that they provide clocking. Obviously, an easy way to remember that is DCE, provide clocking. C for clocking. Data circuit terminating, provide clocking. DTE, or data terminal equipment, do not provide clocking. And typically the DTE is a customer premise equipment that is owned by the customer. This can be the router that's connected to the CSU, DSU. It could be a multi-layer switch that's connected to an incoming Ethernet connection that's being powered by some type of CSU, DSU. It's really anything that the customer owns that doesn't provide clocking and connects to DCE equipment is going to be your DTE. Now, the demarc point, or the demarcation point, is that point where typically the customer premise equipment ends and the local loop begins. Now, in many cases, the way contracts are written, they're written so that anything inside the demarcation point, the company is responsible for maintaining and owning. Anything outside the demarcation point, the WAN service provider is responsible for fixing and maintaining. So that's our demarc between the equipment inside and the local loop. Now, the local loop is that last mile. Typically in the U.S., unfortunately, it is a lot of times copper, especially to houses that are running DSL or cable modem. But it is a copper connection from your box on your in your organization to the CO switch. Increasingly, it is becoming fiber, thankfully, to increase the speed of that local loop. The central office is the local service provider facility that connects to the CPE, the customer premise equipment. So it's a local CO. Now, here's something interesting if you're using DSL. There are limits to the length of the local loop that you can use in order to get DSL. At one time, I think it was 15,000 feet. It has changed drastically. It used to be actually less than 15,000 feet, but I think that's still there is a limit on how far you can be from a CO switch in order to get, or CO DSLAM, in order to get DSL. Then toll network is the network on the backside that your data runs across. So some of our different WAN devices, dial-up modem, you do not see many of them anymore, thankfully. If you grew up in the world where dial-up modems were, when I first began using the internet, I had a 2400 baud modem. The internet was all text-based, and it was a pain to connect to the internet and to actually maintain connectivity. Access servers are typically devices that allow for multiple dial-in lines to come in to an organization or into a service provider. Broadband modems are DSL or cable modems, provide high-speed DSL, and again, high speed is relative compared to LAN speeds. CSU, DSU is a channel service unit, data service unit. Typically, those are DCEs. They are DCEs, data circuit terminating equipment, because they provide clocking. A WAN switch is a multi-port internet networking device in service provider networks, and it operates, typically it can switch traffic using frame relay, ATM, MPLS, those types of items. The router is just what it always has been. It's a layer 3 device that provides routing based upon logical addressing. And then there are out in the service provider network, there can be core multi-layer switches that have the ability to move data across this service provider cloud backbone. Now inside of these, we're going to have two basic ways of moving data across this CO or this provider cloud. One is circuit switched. The easiest way to think of circuit switched is to think of the old-timey phones where you had an operator who literally connected the Jones to the Smiths. So in other words, for circuit switch to work, for A to connect to B, the first thing that has to happen is A must do a call initiation, and it will actually set up a channel across the circuit switch network. So a call setup occurs. Then information is sent, and all the information between A and B will travel the exact same path of the channel that was set up during the channel negotiation. Now, there are ways of doing these. It can be permanent virtual circuits, it can be switch virtual circuits, but for the most part, it establishes a channel, and then the information travels across that channel, every bit of it. Once the call is over, once the data has moved from A to B, that channel is torn down. Again, going back to where you literally used to have someone stand there and connect the Jones to the Smiths. When they got through talking to one another, you would disconnect that particular link. Now, the problem with that is if any part of that channel went down, you would lose the entire connection. Plus, you're limited to how much bandwidth that individual links on the channel can support. So more modern networks, we have a connectionless system which allows us to take data, segment it into smaller pieces, and then just throw it out in the cloud and let it be routed to the destinations in the best possible fashion. Okay, so again, a couple ways you can do that. One is with a connectionless system where full address information is in each packet, or in a connection-oriented system where that predetermines the route for each packet, and each packet only has to have an identifier. So using virtual circuits, permanent virtual circuits. The good news about this is, again, the individual link failure can be overcome fairly easily. You don't have to waste the time to do call setup and call teardown. Plus, you can take bigger chunks and break them into smaller pieces and send them across this packet switch network. As part of that, when we look at our WAN access options, so you're being asked to buy a WAN connection for your company. First off, the decision you need to decide, do you want a private or a public WAN? The problem with a private WAN is cost. Buying a dedicated leased line, okay? If you do that, a T1 1.544 megabits per second, or an E1 in Europe, which is 2.048 megabits per second, and then T3 and E3, which are 44 and I believe 48 respectively. But the problem is with dedicated lines, they're expensive. They also may not even be available in the area that you're looking to connect your office in. Switch networks, you're looking at circuit switched, PSTN, ISDN, public switch telephone network, or plain old telephone system, ISDN. Those are not as common in the United States anymore, especially for actual WAN access. They may be more common in other areas of the world. Packet switched, MPLS, Metro Ethernet. Metro Ethernet is very common in the U.S. now, especially in larger cities. Frame relay and ATM, all of those are available. Now, you can go your own, private way or with a packet switch network, or you can do public. You can take the internet and you can connect to just a standard DSL or business cable internet connection, and then you'll be able to use broadband VPN connection. So you can actually connect with a VPN from your remote teleworker back to your central office, which will probably have a dedicated link to the internet through your local service provider. Here's some other WAN access technologies. You can use satellite, telephone lines, coaxial cable, which is your, the cable modem, DSL, and those items. Now this is something that's in use, fairly new. For the longest time we used synchronous optical networking or synchronous digital hierarchy, SONET, SDH, which SONET is the US standard for the service provider back-end networks, and SDH is the European version, which they're pretty much the same. But we also have what is called dense wave division multiplexing, which is a new way to enable bidirectional communication over a fiber, multiplex over 80 different channels onto a single fiber strand, and also allow each channel to carry 10 gigabits per second of data. So it's basically used in modern submarine cable systems and long haul circuits. So it really gives you the ability. These connections between continents are starting to use DWDM instead of SONET and SDH. So here we have leased lines. Again, in the United States, one of the most common leased lines is a T1, which supports 1.544 megabits per second. E1 is 2.048. T3 is 43.7, which is 44. E3 is actually less, so I missed that. Sorry about that. It is 34.68. And they're good because they are simple if they're available in your area, because they're point-to-point. They have very high quality because they're digital lines. They have high service level agreements. And what a service level agreement is an agreement between you and your ISP of guaranteed bandwidth. So if you pay for a T1 or a T3, you should be guaranteed that you're getting that amount of speed. Also available, again, that goes back to your SLA. Your service level agreement can also have a clause in there that say, in the event this link is down, you will have response from us in no less than 2 hours, or no more than 2 hours. The disadvantage of leased lines are cost. They are some of the most expensive types of WANs. They may not always be available in your area. You may not be able to get a T3 in the New York office. You would be able to in New York, but let's say that you're out in North Dakota, you may not be able to get a T3. But also limited flexibility. Leased lines have a fixed capacity, so you can't go above, you can't burst above those the limits. So if you buy a T1 and you really need a little more than a T1 on occasion, you would not be able to burst above that as you would with some other technologies. Now, if you're stuck using dial-up for your WAN infrastructure, it's going to be extremely slow. It is a circuit switch technology. It can be reliable depending on where you're at. I would say that dial-up access is one of the few things that really has gone the way of the dinosaur very quickly. You just don't see dial-up very much anymore. In the United States, the same can be said of ISDN. ISDN has gone away, now still used globally. It is used for voice lines still in the U.S., but for the most part, moving data across ISDN is not something we do for our data networks. ISDN does come in two flavors. One is ISDN basic rate interface, which is 2B or 2 bearer channels that are 64 kilobits per second, and then one delta or signaling channel that is a 16 kilobit per second, and that is basic rate ISDN, so BRI. or primary rate ISDN, which is 23 B channels, same size, 64 kilobits per second, and 3 D channels. So it's actually 1 D channel, which gives you the speed of a T1, basically 1.544 megabits per second. It is very important that you just know about these because they could show up. They're good to know. Basic rate 264K and 116K delta. Primary rate 23B in the US. That's the T1, by the way. And then 1D that's 64 kilobits per second. Okay. Other WAN technologies is a layer 2 protocol frame relay. Frame relay is non-broadcast multi-access WAN technology. We have an entire chapter on it where you'll learn all about DLCs and virtual circuits and those items later in this particular course. Suffice to say, for right now, the big thing is layer 2 technology uses virtual circuits, and we will discuss this much more in the future. ATM was a promising technology that was up and coming because it can move data, voice, and video across the same link by multiplexing it across a frame, a cell-based structure. And in those cells, you had a fixed length of 53 bytes, which made it easier to actually work with because you always knew there were 48 bytes of data and 5 bytes of header. And the problem with ATM is it was designed to be scalable and very fast, but it was overtaken by very fast Metro Ethernet connectivity in our networks. And it was very expensive. It also had, when you were trying to configure it, it was very, the nomenclature and the naming for items in ATM were very tough for someone coming from an Ethernet world. And so, for the most part, ATM has not taken hold in the US anyway. This has, though. This is huge. This is basically, we put fiber in the ground, and then we can connect between our sites using Metro Ethernet. And this is one of the things we do at the college where I'm employed. We have a Metro Ethernet connection between our site and one of our remote campuses that allows us to run extremely high-speed connectivity to that campus. For the most part, it's not that expensive. It is, up to 70 kilometers in cable length, depending upon what you've got running on it. You can also use some vendors are now doing MPLS over Metro Ethernet over MPLS, or Ethernet over MPLS. So it's really become kind of the go-to high-speed connectivity if it's available in your area. In fact, it's even Metro Ethernet's even starting to take the place of frame relay. Now, this MPLS, this is a service provider WAN technology. It is what can be used inside the cloud of the service provider. You can connect with any technology you want into this MPLS cloud, and then MPLS is used to move information across. Now, this is a very simplified way to look at MPLS, and it's not completely correct in the analogy I'm going to use, but MPLS is very similar to not frame tagging, but with VLAN tagging. In other words, as information comes in, the information is tagged as being part of a certain flow, and then that information is moved through the MPLS cloud based upon that. Very similar to the way information that comes in on a port would be tagged with a VLAN tag, and then it could move to whatever VLAN is needed. That's not an exact analogy, but that's a good way to kind of think of MPLS and how it keeps up with the information going across the service provider's network. MPLS is a CCNP topic, which is covered in much more detail in that particular course. VSAT, very small aperture terminal, or VSAT creates a private WAN using satellite. Obviously, if you can afford VSAT, you're going to be spending thousands and thousands of dollars. Large military organizations, large governments, they can support this, and this is actually something used quite a bit by military organizations, especially when they have to develop or deploy networks in the field. Here's an example of DSL. DSL is a fast service. It is available in a wide variety of areas. It is an always-on technology, so you always have connection. You have a DSL modem, and then you have connection to a DSLAM, which is a DSL access multiplexer. This is that link right here, this local loop that I talked about has a distance limitation. If you're too far from the DSLAM, you cannot get DSL. DSL basically are two types, asynchronous and synchronous. Most DSL is asynchronous, which means you have a faster download speed than upload speed. A synchronous DSL would mean you'd have the same speed downloading as uploading, but most DSL is asynchronous DSL. Another very common, especially home technology in use, is a cable modem or cable modem connection. Again, cable modem provides always-on 24/7 connectivity. You've got to have a cable modem that then connects to, typically you may have, there are some that have actually a cable modem built into a router, all as one device. But cable modem comes into your router, and then your router provides connectivity to your teleworker. Again, high speed. There are distance run limitations for this also, just like there were for the DSL. Then you have wireless. You've got municipal Wi-Fi, where some cities are beginning to provide wireless to their local residents, and then WiMAX, which is worldwide interoperability, and satellite internet. Those are some others. Satellite internet, the only thing to be aware of is you're looking at large delays because of distances. Here's some of some new technologies, 3 and 4G and LTE. It is actually becoming now where you can have almost as fast a connection using 4G LTE as you can with some always-on connections such as DSL and cable modem, depending on where you're at and what area you're in. Another thing we can do, and this is where we start connecting across the public internet to allow our remote sites to connect securely. And we do this with VPN, or virtual private network tunnels. There are two primary types of VPNs, site-to-site VPNs, and you'll notice the key point on a site-to-site VPN is where the VPN tunnel ends and begins. So you'll notice with a site-to-site VPN, the tunnels originate and end at networking devices. So in other words, these hosts inside the company headquarters in branch A and branch B, these hosts have no special software on them. They really don't even know their traffic is moving through a VPN tunnel, because all of that on a site-to-site VPN is being handled by the networking devices between these sites. In a remote access VPN, you'll notice the tunnel goes all the way to the teleworker. Now this is important because imagine if you have a group of salespeople who travel around the country, and every night they're in a different city in a different hotel. Well, you obviously cannot control the router at the hotel those individuals are staying at. So you cannot do a site-to-site VPN because you don't control the router at the hotel that they're staying. However, you can load on the individual teleworker's machine something like Cisco AnyConnect, which allows them to create a VPN tunnel from their individual PC all the way across the internet back to the corporate headquarters. They'll get an IP address on the corporate headquarters, and they will have access, if you've configured it this way, to every single resource on the corporate network they would have if they were inside the network itself. So that is a huge cost savings for several reasons. First off, you always make your teleworkers stay at a hotel that's free internet, free high-speed internet. Therefore, you don't have to maintain dial-up connections for them. And the only additional cost is the networking device at your company head office and the setup and maintenance of the software on the teleworker's PC. So, big cost savings. It does provide security because those tunnels are secure, that everything going through them is encrypted. It's scalable, and it's also compatible with current broadband technology, so you don't have to do anything special in order to make this work. Now, what are we going to buy for our particular businesses? You know, why did SPAN go from a small branch using DSL or cable modem to, you know, a leased line to an MPLS cloud. A lot of that is, what is the purpose of your WAN? What are you trying to do? Do you want to connect your central office and a bunch of teleworkers? Do you want to connect your central office and 2 or 3 remote branch offices in the same city? If so, you may want to investigate Metro Ethernet. What's the geographic scope? Are we talking about connecting sites in multiple countries? Are we talking about sites in multiple cities or within the same city? How much traffic are you going to have? How much actual data moves between these multiple sites? All of those are considerations when you start looking at what WAN access method to use. Do you need support voice over IP? Do you need support quality of service tags remaining on your data all the way through the network? All those are important items to consider. Then, always consider price. Price is always a huge thing no matter what. So, again, should it be a private or public infrastructure? Should it be dedicated or switched? For a public WAN, should we use a site-to-site VPN or should we use a remote access VPN? What options do I have locally? Who are my ISPs locally that I can use? And what's it going to cost me? Big items there. So, when you go to look at WAN technologies, the big thing to remember is that WAN technologies deal with layer 1 and layer 2 technologies. So in other words, we have our data link protocols like frame relay, MPLS, ATM, those protocols. Then we have our layer 1 standards, which actually deal with our standards for how we put signals onto the medium or media itself. Hope you enjoyed this lecture and look forward to working with you with others in the future.